Today we're starting our next unit. We'll continue it tomorrow and Friday, and then we'll go back to reviewing for your area test, which will be next week. Remember that you have your area quiz tomorrow on worksheets 1 through 3. So it won't include regular polygons and it won't include circles, but everything before that. So we're going to start a unit on solid geometry, which is basically three-dimensional geometry. Everything we've done so far has been flat. It's been two-dimensional. For this unit, it'll be three-dimensional. And the surfaces of those can be either flat or they can be curved, either one. Each flat surface is called a face. That's the term. You have to know the terms in this unit. If you don't learn the terms, it will not go well for you. Okay? So each flat surface is called a face. So that's basically anything you can put your hand on and touch, right? The intersection of two faces is called an edge. So that's where two faces meet, and the intersection of two edges is called a vertex. So here's a picture of a pretty simple rectangular solid. Each of these rectangles is a face, right? You can touch that. You can put your hand along it. That's a face. Where two faces meet is an edge, and where two edges meet is a vertex. So face, edge, vertex. You need to know all those terms. Vertex is not really a new term for you. We've used that a lot this year. So there are different kinds of three-dimensional figures that we're going to be looking at. The first kind is a prism, P-R-I-S-M, not prison, but prism. It's formed by two parallel, congruent polygonal faces called bases, connected by faces that are parallelograms. Now, most of the time they're rectangles, but they can also lean to one side or the other and be parallelograms. Okay, so you can imagine this figure, instead of being straight up and down, leaning over to the side, then the faces on the sides would be parallelograms. So here we have two bases. This would be called a triangular prism because the bases are triangles. Base does not mean what's on bottom. Okay, I could take this and turn it on its side and it would still be a triangular prism. The bases in a prism are the two things that may not be a parallelogram. If there's anything that's not a parallelogram in a prism, that's the base, even if it's not on bottom. Okay, a cylinder is formed by two parallel congruent circular faces called bases connected by a curved surface. Okay, so a prism and a cylinder are very much alike. The only difference is one has a polygon for a base and the other one has a circle for a base. And so when we're studying these, when we do prisms, we'll do cylinders at the same time because they're almost exactly alike. The difference being a circle instead of a polygon. That's the only difference. Now, a pyramid is formed by a polygonal base, and the one that you're most used to, like if you think of Egyptian pyramids, what's the base of an Egyptian pyramid?
Square.
It's a square. Those are square pyramids. But you can have triangular pyramids, you can have hexagonal pyramids, you could have a trapezoid for the base of a pyramid. It just has to be some kind of a polygon. It doesn't matter what. So again, if you have anything that's not a triangle in a pyramid, that's going to be your base. So you just have one base in a pyramid, and then everything else is a triangle that meets at a common vertex. Similar to that is a cone. A cone is formed by a circular base and a curved surface that connects the base to this single point up here called the vertex. Okay, so those are the four basic shapes that we're going to be looking at throughout this unit. Let's go on to page 2. One special kind of prism that we'll look at in some examples is a cube. A cube is a prism with 6 square faces. Okay? A simple example of something that is at least close to a cube, although most of them have the corners knocked off, is a 6-sided die. Okay? That is a cube. Every face is a square. Any other prism or pyramid is named with its base, and that's what I was saying just a moment ago. So here, this is a triangular prism. I know it's a prism because it's got these 2 triangles that are congruent and parallel to one another. This is a pentagonal pyramid. Okay, because it has a pentagon as a base. Anything that's not a triangle in a pyramid is going to be the base. Anything that is not a parallelogram in a prism is going to be the base. So one of the things that you'll be asked to do on your homework tonight will be to classify figures. So this one says classify each figure. Name the vertices, edges, and bases. All right, so for this first one, what kind of a base does this have? And be careful, as a rectangle. So this is a rectangular pyramid. It might be a square, but we don't know that for certain. Then we want to name the vertices. Well, that's pretty easy. It's just all of, people think of them as the corners, the points. We've got Q, R, S, T, and X. Then it says, name the edges. Well, there are 2 different sets of edges in this one. There's segment QR, segment RS, segment ST, and segment QT. Those are called the base edges. Because they go around the base. And then there are 4 other ones, XQ, XT, XR, and segment XS. Because these are on the sides of the pyramid, these are called lateral edges. Lateral means sideways or to the side. So we've got base edges around the bottom and lateral edges on the sides. And then finally it says name the bases. There's only one base, and it is rectangle QRST. All right, let's take a look at number 2. What kind of a figure is that? It's a cylinder. Every now and then you'll see something described as a circular cylinder, You can have other curved things for bases in cylinders, but we don't really deal with that, so we're only going to deal with circular cylinders. There are the eyes. You okay? So this is a cylinder. So for vertices, there are none. Cylinders don't have vertices. Likewise, they don't have edges either. But they do have bases. The bases here will be circle P and circle Q. Okay, any questions about that? All right, one thing that we'll be using from time to time is this idea of a net. A net is a diagram of the surfaces of a three-dimensional figure that can be folded to form the figure. So the net is going to be two-dimensional, and it's like, you know, if you fold it, if you cut it out and fold it up on the dotted lines or something, what does it make?
Is it one of those like origami things?
Not so much origami, because origami is you fold the paper and you end up with something, but this is just, I'll show you an example.
So that would be a 5-sided pyramid.
I'm sorry?
So that would be a 5-sided pyramid.
Exactly. That would be a five-sided pyramid, and what do we call a five-sided figure? A pentagon. So this is a pentagonal pyramid.
Doesn't have to be 3D.
Yeah, can you fold those like flaps if you fold it up?
Yeah, if you were to cut this out and fold it up, what would it make? This one some students find hard at first, but
Yeah,
It's a cone.
It's a cone.
it's a cone.
hold a spine right now.
So this would be the base, and the lateral part would go up to this point up here. I think cylinders are easier to see. You don't need to draw this, but a cylinder would be something like this. Actually, that circle's a little small. That's probably closer to being right. Right? Where if you rolled that up, you would get a cylinder. Part of it is it's got two circles. Well, that's the only thing that we have with two circles in it. All right, last thing that we're going to take a look at is the cross section. This is going to be an important idea for us when we get to talking about the volumes of these three-dimensional shapes. And you actually did a little bit of this if you were here in, I don't know if it's in the 7th grade book or the 8th grade book, one of the two, where you do a little bit about cross sections. Basically, the way I think of it is, you've got the three-dimensional figure is made out of something soft like clay or Play-Doh, and the other thing is a wide-bladed knife. Okay, so here, if you were to slice this cone across here and look at where you took it apart, what would be the shape of the pieces that you couldn't see before?
So did it cut across like the top? Is it two bases?
Well, so it's going to be two what things put together?
Circle.
Two circles. So the cross section is just a circle. So the cross section would be just this piece right in here. What would the cross section of this one be if I sliced, instead of horizontally, if I sliced it through the vertex down to the base? What would that be? It'd be a triangle. So if I was to take a cone, actually, let me get one. So if I was to take a cone and this was solid, and I was to cut it straight down from the top, do you see how it would go across the bottom like that, and the two sides would be like this? So when you take it apart and look at the inside part, what does that inside part look like? So it's just going to be that triangle. Okay? Any other questions about this? Okay. Then your assignment is in the book, and you can go ahead and get started on that. And again, don't forget about your quiz tomorrow.